Hello, Geometry, Chapter 4, Lesson 5, Dilations. Okay, so we are moving now from what they call rigid transformations. Those are ones where the shape stays the same size, same shape as you translate it, reflect it, rotate it, to dilations, which are non-rigid transformations, as in the size will change. So as you can see here, this would be an example of a dilation. Something's getting bigger or something can get smaller. Now in this case, this is an enlargement. Okay, we're going to call this on page 112. This is an enlargement because A prime, B prime, C prime is larger than triangle ABC. Okay, it's bigger, it's larger, so this is an enlargement. If these apostrophes were down here, then it would be a reduction. Okay, so an enlargement versus a reduction. So when you look at this, you always have a point that you're enlarging around. And a lot of what you'll see today is going to be enlarging around the origin 0, 0. Makes things very easy. Now I'm going to look at when I connect these. Notice it's straight. They go through there, right from there. Each one of these would, if I'd go through there. B, this point is at 1, 3. Okay, notice that point at 1, 3. B prime is at 2, 6. And these relationships are going to be important here. So if I go from 1, 3 to 2, 6, if I take both of these times 2, then I get this point. If I look at the point A is at 2, 1. A prime is at 4, 2. Okay? So 2, 1, if I take both of those times 2, I get 4, 2. Same with C. This is at 3, 2. This one is at 6, 4. So we say this has a scale factor of 2. Scale factor of 2. And you can tell that from your points. 1, 3, 1 to 2, 6. If we were going to find the length of this, okay, here's our triangle. This is 1 and this is 2, so that'd be the square root of 2 squared plus 1 squared, that's the square root of 5. And if I go up here to this length, this is 2, this is 6, 6 and 2, that's the square root of 36 plus 4, so that's the square root of 40, which reduces, that's the square root of 4 times the square root of 10, that reduces to right? 1, 2, that's 3. That's my problem. I knew something was wrong here. This is 3 here. Going back to the small one. 3 squared plus 1 squared, that's the square root of 10. Square root of 10. This one is 2 and 6, so that's 36 plus 4. That's the square root of 40. You can do the factor trees with it. It's the square root of 4 times the square root of 10, so that's 2 times the square root of 10. So you notice that length got twice as long. It got twice as far away. So this is a scale factor of 2. So what does that mean? That was on page 112. We're going to go all the way over to page 114 now. And we have our vocab here. A dilation is a transformation. It is a type of transformation. It's like a translation, reflection, dilation. Rotation, where a figure is enlarged or reduced with respect to a fixed point. With respect to a fixed point. And that fixed point is called the center of dilation. So we'll just say this is the fixed point. Mostly it's the origin that we're going to face. Okay. The scale factor, this uses the variable k. Scale factor uses the variable k. And it's the ratio of the lengths. I think we use side length of the corresponding sides, so uses the variable k, ratio of the lengths of the corresponding sides of the image and pre-image. Okay, image is going to go on first. So we can say it's the image lengths divided by the pre-image lengths. So image lengths over the pre-image lengths. This scale factor k, when k is greater than 1, or k is greater than 100%, because 100% is the number 1, you have an enlargement. Okay? You have a reduction when 0 is less than k, which is less than 1. Or 0% is less than k, which is less than, not equal to, less than 100%. Okay? You may have percentages. So if you have percentages, you have to convert them to a decimal. Another thing to add to this, when k is negative, the object is also rotated 180 degrees. So if k is negative, you also have a 180 degree rotation out of it. So here's your points, the main thing that we're seeing here. So if this is our point, our center of dilation, okay, notice dilation. We kind of, when you say it, it kind of sounds like it has an A in it, dilation, but it's really a dilation, no A in there. There's our center. So this is our pre-image, and then this is our image. So you notice how the pre-image, PQR, is smaller than the image, P prime Q prime R prime. That makes us an enlargement. Okay? If P is not the center point, C, then the image point P prime lies on C prime. Okay? So since that's not the center point, you can draw a ray through there to that point right there. This is important here. The K is a positive number in this case because we have no rotation. So K is the C, K equals CP prime. That is the big line here. So let's put a number on there. CP prime is 20 divided by CP. So let's say this right here is, we'll make it easy, 10. So in this case, if they want to know the scale factor, or the value of it, you'd say K equals 20 over 10, which would be 2. It's twice as big. That means the area is 4 times as big. The area has square units. Wish they had some of those questions. Unfortunately, they don't. We may work on that some more. Okay, so here's the rule on the coordinate plane. So if we're on the coordinate plane, you have a point xy, it's the pre-image point. Then this image, after a dilation centered at the origin, with a scale factor k, is the point P prime of kx and ky. So we can say, give the image of a point A, which could be at 2, -3, after a dilation, dilation with k equaling 5. K equaling 5. So then we'd say, okay, A prime is going to be 5 times 2 and 5 times -3. So just take the 5 times both of those. That makes A prime at 10, -15. It would be 5 times further from the origin than what it was. So A prime is 5 times further from the origin than A. Okay. What if they came about with, let's use the same point, they say K is going to equal 75%. They gave you a percentage. then what you have to do for A prime is you have to take 0.75 times 2 and 0.75 times negative 3. So remember, any percentages, convert those into decimals. So that would be 1.5, and 3/4 of 3 would be 9/4, so that'd be 2 1/4, negative 2.25. That would be a reduction because now it's going to be closer. So A prime now is 75% closer to the origin than what it was there. In the practice, find the scale factor of the dilation, tell whether the dilation is a reduction or an enlargement. So first, find your original. Okay, here's P. That makes that the pre-image. And notice it's getting smaller. It's getting smaller here. Okay, so here's a pre-image. We know this is a reduction because it's getting smaller. To find the scale factor, remember you need the ratio for the image. Okay, so if this is 2 down here, this has to be 2 up here because the whole thing is 4. So you're going to take this, K is going to equal CP prime over CP. So CP prime is going to be 2. CP is the total length, that's going to be 4. 2 over 4, K equals 1/2. So you have a reduction, and K equals 1/2. Okay. Here's C. C is going to P. So here's our center of dilation, and then here's P prime. This is going to be an enlargement. So our K is going to be CP prime over CP. So CP prime is 25. CP is 20. So K is 25 over 20. Reduce that, divide by 5, so you get 5/4, which could be 1.25, or you could say that's 125%. So your K value could be written any one of those ways: 5/4, 1.25, or 125%. Finally, on 3, try this, come back, see if you got it right. Okay, CP is smaller, CP prime is bigger, so this is another enlargement. CP prime is 27, CP is 9, 27 divided by 9 is 3. So your K equals 3, or you could say that is 300% growth. Okay, that means CP is 3 times the length of what, CP prime is 3 times the length of what CP is. Okay, a little graphing. Graph the polygon and its image after a dilation with scale factor K. Scale factor K. Okay, here we go. So A is negative 3, 1. B is negative 4, negative 1. C is negative 2, negative 1. Okay, so there's A, B, C. Get those points on there. Get this moving. Let's get this party started. Okay, so there's our pre-image. K is 2. So I know my rule is going to be xy is going to go to 2x, 2y. xy is going to go to 2x and 2y. So A is negative 3, 1. A prime is going to be 2 times x, negative 6, 2 times y, 2. So 2 times negative 3, 2 times 1. You can write those steps out if you want. B was negative 4, negative 1. B prime, so if you need to write steps, you're going to take 2 times negative 4, and then 2 times negative 1. So we're going to get B prime to be at negative 8, negative 2. And finally, C is negative 2, negative 1. C prime is going to take both of those times 2, so negative 4, negative 2. So let's check it. A is negative 6, 2. B is at negative 8, negative 2. And C is at negative 4, negative 2. Got my labels on there. And what you want to check is you want to imagine or take lines through each one of those in the origin. So if I go from the origin, there should be a straight line from the origin to both of those points. Looks okay. Straight line from the origin to B prime and to C prime. So that looks okay. So these lengths are twice the distance from the origin. The area is 4 times what this area was. So 4 of these black triangles would actually fit in this red triangle. So the lengths are multiplied by 2, but the areas are actually multiplied by 4 in this case, 2 squared. Okay, next one. This is going to be a reduction. It's going to start with something big and get smaller because this is less than 1. First one was an enlargement. So P is at negative 10, 0. Q is at negative 5, 0. R is at 0, 5. And S is at negative 5, 5. So we have a parallelogram. So we need to take, that's nice they use multiples of 5 here. So our rule is going to take x, y, and go to 1/5 times x, 1/5 times y. So if P is at negative 10, 0, take both of those times 1/5, P prime would be at negative 2, 0. Taking it times 1/5 is the same as dividing by 5. Okay, Q is at negative 5, 0, so Q prime is going to be at negative 1, 0. R is at 0, 5. R prime is at 0, 1. And S is at negative 5, 5. S prime is going to be at negative 1, 1. Negative 2, 0, negative 1, 0, 0, 1, and negative 1, 1. So P prime, Q prime, R prime, S prime. Again, everything from the origin, if you're going to connect your lines, everything from the origin through those points to the outside ones should be in line with each other. Okay? And those distances now to those points are 1/5, what it was. The area is now 1/25. 1/5 squared. 1 squared over 5 squared. 1/25. That means you can take 25 of these smaller ones and fit them in the big one. Okay, find the coordinates of the image of the polygon after a dilation with scale factor k. We're going to do this on paper. I'm also going to graph this as well because you notice the negative there. We'll see how we can fit with this. I just realized that's going to be pretty big. Okay, so we're going to take, all you have to do here is if you want A prime, you have to take negative 6 times negative 3 and then negative 6 times 1. So A prime is going to be at 18, negative 6. B prime, take both of these times negative 6. So you're going to get 24 and 6. C prime, take both of them times negative 6, so you can get 12 and positive 6. Okay? I want to show you that rotation that happens real quick. So let's say I get A is negative 3, 1. B is negative 4, negative 1. And then C is negative 2, negative 1. So there's that image. Let's just say K is going to be negative 2. That way we can fit this on here. So if K is negative 2, A prime is going to be at 6, negative 2. So you notice how it completely moved the location here. So the negative moved it to the other side of the y-axis and the other side of the x-axis. Okay. So A prime would be at 6, negative 2. B prime would be at 8, 2. There's B prime. And C prime would be at 4, 2. 4, 2. So you see how you have a 180-degree rotation and an enlargement. Okay, by 2, that means your area has a scale factor of 4. So there's the rotation that happens when you get a negative k value. But for these questions, all you have to do is take negative 0.25 in this case and multiply this by every value. So you're dividing by 4 when you dividing by negative 4. So p prime would be negative 2, negative 1, divided by 4. So we're dividing everything here by negative 4. Q prime would be negative 5, 2. R prime, go ahead and finish this up. So R prime is negative 4, negative 1. S prime would be 0, negative 3. Okay, some words. You design a poster on an 8.5 inch by 11 inch paper for a contest at your school. The poster of the winner will be printed on a 34 by 44 inch canvas to be displayed. What is the scale factor of this dimension? So you want the new size divided by the old size. That's kind of like the image divided by the pre-image. So if 34 is the width, 34 is less than 44, so 8.5 is less than 11. So if you just take 44 divided by 11, you get 4. If you take 34 divided by 8.5, you'll also see that you get 4. So what is the scale factor? K equals 4. It's 4 times the size. Okay, a lot of times they print it based off the area that you're printing, though. So if your scale factor is 4, though, the area that you have to print is now 4 squared, or 16 times bigger than what it was. So if it cost $5 to print this, it's going to cost 5 times 16, or $80 to print this. Even though it's just 4 times bigger, you're printing 16 times the area, so it's going to cost, take it times 16 there. Biology book shows the image of an insect that is 10 times its actual size. The image of the insect is 8 centimeters long. That's the actual one. What is the actual length of the insect? Oops, sorry. So the insect is 8 centimeters long. So the image in the book is 8 centimeters long. What is the actual length of the insect? So this is 10 times what it is. So 8 equals 10 times the length, whatever it is. So if you divide by 10 here, you would get that the length equals 0.8. So you can say 0.8 centimeters, or how many millimeters would that be? Move the decimal 1 to the right, 8 millimeters. Okay? So the actual length of the insect. So you know its K is 10. The insect is 8 centimeters long. You can think about it this way. This is the one in the book. So you could say 10 equals 8 over the original. You can solve for the original there. So the original equals 8 over 10, which is 0.8%. Okay, that covers it for now. There's so much more we can cover with this, but this will be it for this lesson. Good work. We got one more until we are done with Chapter 4. You guys are doing well. See you in class.